Thanks, Adam. So I'm here to talk about making websites accessible. And since that is a pretty widespread topic, I'm focusing on the part making websites accessible to people who can't see well. And to start, I'd like to illustrate what that means. There's a picture that I took from the hotel last night, just out of the window. And without my glasses, like if I take them off, it looks a little like this. So putting glasses on helps, like I can restore my sight with that. But it might be worse, it might look like this. And by then, like glasses might not help anymore. It might still be worse. Maybe all your eyes are producing like this, some blob of light, but it's not really enough to make good use of your eyes. And this is probably something like labeled legally blind. Your eyes still do something, but it's not really useful. So how many are affected by this? If you look at the worldwide numbers, there's about 42.7 million blind people worldwide. And there's about 272 people with low vision. So like anything between sees well and is blind is considered low vision. These two numbers taken together make up the entire population of the United States. That's a lot of people who are affected. So technology can help those people. Like there's some technology specifically designed for people with, for example, vision disabilities. Here's one example. This is the iPhone color identifier app. It works by basically taking your iPhone, running the app, and then pointing it at something. And every 3 seconds, it will read out the color that it can see in the center of the screen. And it seems pretty simple, and someone can see well, and also can see all the colors, might not see much use in this, but for someone with color blindness or who can't see at all, this can be quite amazing. And the blind blogger Austin Seraphin wrote about this. He wrote, "I went outside. I looked at the sky. I heard colors such as horizon, outer space, and many shades of blue and gray. I spent 10 minutes looking at my pumpkin plants with their leaves of green and lemon ginger." The full blog post where he writes about his experience with the iPhone and this app is even more inspiring. For Austin, who's blind since birth, this is the first time that he could experience color for himself. There's many more positive examples of technology that can help people with disabilities. But a lot of the sites on the internet aren't accessible at all, or they're in a really bad state where it's really hard to make any use of them. To illustrate what it means to use the internet when you can't see it, I want to show you this as an example. This is like a GPS, a navigation device, and it helps you in a car or maybe even on foot to get from point A to B. Imagine this without the screen, just the voice telling you go left now and go right. If you've used such a device before in a car, it can be quite confusing if you only listen to the voice. Like sometimes the instructions come too late, sometimes too early, you're not sure should I turn left now or in 200 meters later. But this is basically what blind users have to deal with when using a computer or also a phone, and they can't see the screen. So they use something called a screenreader, which is basically this without the screen, and it runs on your computer or your phone, and it reads everything, not just the browser. So, but in order to use the internet, it obviously has to read stuff that the browser contains. Here's an audio example of me trying to browse a website with a screen reader. Please listen and try to figure out what is happening.
Each page has 17 links, 4 auto web spots, 2 form controls. Open web item rotor, headers 0 items, links 17 items, auto web spots 4 items. Amazon edit text blank.
So this might be a little confusing and hard to follow. The voice is somewhat fast. An actual screen reader user would set it probably to like 5 times that speed, but then you wouldn't understand anything. To get an idea what actually happened, I'm going to show you the same video again, this time with the visuals, like what the screen actually shows.
Each page has 17 links, 4 auto web spots, 2 form controls. Open web item rotor, headers 0 items, links 17 items, auto web spots 4 items. Amazon edit text blank.
So a few things that you could hear here. It said no headers. That's really bad because headers, as we learn a little later in more detail, are really useful for navigation when you use a screen reader. It also said added text when we put focus on this input field. Basically means like that's the description this particular screen reader uses for any kind of text input. But it's not really describing what the input is about, so we don't really know what this input does. The sad thing is that this page was actually specifically designed for screen reader users. I only found it because I was browsing the main website that they have with a screen reader. And there's plenty worse examples, like sites that are even like much worse than this. Like there's all kinds of broken, like this, or maybe like that, or something like this. It seems like fun to use. So I think we can do better, and I want to show you how. And I want to give you arguments for what I dub convincing your boss. So last time I gave this talk, someone from the audience told me a little story afterwards that he was working in a team. He's working for a bank, and their team also maintains their online banking site. And so for a long time, they didn't really care about accessibility. They probably knew very little about it, and no one cared. And then one day, they actually got a customer who called and complained about the broken online banking. He was blind and he was unable to use it. Or maybe it was low vision, but he was unable to use the online banking properly. And suddenly, accessibility became a high priority for them because they actually care about their customers, even if they maybe don't think about what all their customers are doing all the time. So, and based on that, you might ask, like, do you want to wait for your customers to call and see what problems they might report, or do you just hope that they don't move on to the competition if they can't use your site? Maybe they don't bother calling and just find something else that actually works. So that's one perspective from this. There's others. Making websites accessible can actually help improve the user experience. For example, at the same hotel where I was taking the picture, I was trying to sign into the hotel Wi-Fi on my phone. And for that, I had to accept the terms and conditions. So there was a tiny checkbox and lots of text next to it. So I tried to tap the text, but that wouldn't do anything. I actually had to tap on the tiny checkbox. And then I had to select 1 day or 3 days or 5 days, all were free. But I had to select the radio button. And that was also tiny. And again, tapping the label didn't work. So that was pretty annoying for me. For someone using a screen reader, this would be much worse, since the screen reader would say, hey, here's a checkbox, but I don't know what that is about. So making pages accessible would improve this and others for everyone. There's also another aspect. If you make your website accessible, and that should start with making it keyboard accessible, might actually help a lot for any power users. For example, I work as a freelancer, and pretty much all my projects are built on an hourly rate. So every day I have to log hours. And when I do that, I want to spend as little time as possible in that, since logging hours, no one pays for that. So I try to use the keyboard as much as possible. And this site I use, it kind of works, but it could be much better. And I'm sure there's plenty of examples where people can use the mouse, but they would just like to use the keyboard, especially to fill out forms. It's so much faster. And if you can use the keyboard, it probably means that any screen reader user has an easier time as well. There's this thing business is usually eager to make search engine optimization. It's more tangible. You can see how this has get more profits if more people get to your site and buy stuff. But if your site basically contains an empty body tag and then some JavaScript that actually loads the content with Ajax, not only will this really bad for the search engine, since it doesn't see any of the content, but also be really bad for the screen reader user. There's ways to deal with Ajax and still make it work for the screen reader. We'll take a look at that later, but it really helps, and it's much more effective to start with proper markup on page load, since that will also address the search engine. It might also mean that you just get more customers, since if your competition has a bunch of inaccessible site and yours actually works, people might shop more on your e-commerce offering. It's easy to imagine that someone who has trouble, who can't see, therefore has trouble leaving the house. It's easy to imagine how you might profit a lot from being able to shop all kinds of things online. And there's laws to consider, especially this applies especially to government websites. There's a lot of nations that have legislation that require government websites to be accessible. Here are a few examples from the US, Canada, UK, and Germany. And the example from Canada is actually interesting. While their standards are pretty complicated, they actually started, at least I think in Ontario, started forcing pretty much every business to make their websites accessible. It's not like there's certain timelines involved, like large businesses have to do it by 2014, smaller ones by 2015. But this is basically something that we can expect to apply in other nations as well. Eventually, probably every website has to be fulfill some level of accessibility. So these are 5 sample arguments. I hope that, depending on your situation, mixing and matching the combination of these could help. There's one more option, which kind of works in the same direction what Monica was talking about earlier today. Sometimes you just have to start something, ask for forgiveness later instead of permission in the first place. Do some testing, do some fixing, demonstrate how easy it is, and then demonstrate that to your boss and hopefully get more time later on. So let's look at actual testing. The first easy test is to ask, do you use a capture? If you are, do you have an audio alternative? And if we both answer that with yes, we might think, hey, I'm good. Okay, the blind user can use the capture, but we have the audio alternative, so everything is fine. So if you've never listened to one of these audio alternatives, this is the Google audio capture, and I'd like you to listen to it.
Please type every digit you hear. Spaces are not required.
So I actually tried to solve one of these a few times and I failed. So my recommendation is don't use captures. They suck. There's just no way to make these accessible. What else can we test? There's a few options. There's automated test tools like the W3C validator. There's keyboard testing, which is more manual, but really easy to do. And of course, eventually we also have to actually test with screenreaders. Let's start at the top. This tool is still pretty useful, not really about the W3C validated badges. Luckily, these have pretty much disappeared by now. But it's good to look for actual markup problems. For example, it can find unclosed elements or duplicate IDs or invalid nesting. And whenever these problems don't cause visual issues that we might just normally notice, they might actually mess up the screenreader. So it's good to spot these with a validator without having to review every single line of code manually. Once we've done that, or maybe probably do that every once in a while, or figure out a way to do this automatically as well, we can do some manual testing. My suggestion is to start with keyboard testing. It has basically no setup. It requires very little effort. The idea is to put away your mouse, not touch your touchpad either, and then use the tab key for basic navigation and interact with everything that can be interacted with. And try to actually get some task that your site supports. Try to get that done. I want to show you an example here using the Wizz Air site. Wizz Air is an airline in Europe, and in this video I'm looking for a flight, and I'm using only the keyboard. And you can see, for the most part, the buttons that are pressing displayed in overlay at the bottom. I'll pause here real quick. So And the first step, I just filled out the form, used the date picker and the select to find the airports. That worked out pretty well. I could just hit enter to submit the form. So far, everything's fine. And now in the next step, I'm trying to actually select the flight and try to follow along what happens here. So what actually happened that I pressed tab and tab and tab and tab, and there was nothing really much happening except when finally there was an element that received focus that was further down on the page, so the page scrolled. But until then, apparently there was something that could receive focus, but I couldn't see it. So this is basically completely unusable if you're only using a keyboard, if you can't use your mouse for whatever reason. And it's certainly not effective for someone who has to book flights all day. So as one particular example of the issues on this page, there's a bunch of them. Let's look at this button. So this is for like showing earlier flights or something. And as you can see here, the button is actually an anchor element, but doesn't have an href attribute. So this basically tells the browser, this is just in regular elements, and don't bother making this focusable. So there's no way to access this with the keyboard. This affects screenreader users as much as it affects anyone who just tries to use this page with a keyboard. So this is pretty trivial to fix. Like, you can just make the anchor focusable, for example, by giving it, in the third and fourth example here, giving it an href. The value probably should be something better than this, but at least with an href attribute, it will be focusable. Or if you start with a span and install that as a button, you can use the tab index attribute and give it a value of 0. Or better yet, you start with a button element, or if you have an actual link that points to some resource, you use the anchor, but don't abuse anchors as buttons. And then you can still put other JavaScript behavior on top. Here's two more quick examples of bad markup and how to improve that. So this is from the page I showed you earlier. Like, there was supposed to be an e-commerce site, but it was really bad. Like, they were not using headers, which are pretty useful. And they didn't put any alt attributes on their images. You probably heard that before. So the alt attribute should actually be description of the image, that should be some degree of useful. And if the image does not have any purpose, like if the content has a purely visual decoration effect, then you still use the alt attribute, but you put an empty string inside. That basically tells the screenreader, ignore this one, which is much better than having the screenreader read out the file name. One more example. So another airline site, they use tables for layout. Obviously, that's not a great idea. And then they had like just a TD with the label and an input separately. And so the screenreader can't really tell like, how is this input, what's the purpose of the input. It's really easy to just use the for and ID attributes or just nest the input inside the label. These are all pretty trivial, but they're often missed. So that's basically where you have to start. And then you can actually start testing with screen readers. I have two recommendations to start with. There's NVDA on Windows, which works well with Firefox. NVDA is free to use, it's easy to install, and has a pretty decent market share. So there's plenty of people who actually use it. If you're on a Mac and don't want to bother with a virtual machine at first, you can go into System Preferences and enable VoiceOver there. And then test with Safari, and I think by now Chrome also works pretty well. You just have to make sure that you have the latest version of OS X, since VoiceOver comes bundled, so it only gets updated when you update the operating system. Kind of like Android in the browser, at least. Anyway, there's two more screen readers to consider. There's JAWS, which has pretty much the biggest market share. This is Windows only. There's a demo version, which you can use for 40 minutes, then you have to restart your computer. If you put it into virtual machine and just pause the virtual machine while you not use it, you can pretty much like test it every once in a while for a few minutes and don't have to bother much with restarting. And works well with IE and Firefox. There's also mentioned screen readers on screen readers on phones before. I have a video that shows the screen reader on iOS, but since kind of low on time, I have to skip this right now. But the video is online, and you can find it in my slides online as well. For now, I want to talk a little bit more how the desktop-based screen readers actually work. They all share something that I, for now, call the virtual cursor. They each use a different name, but virtual cursor is a good description. It's basically one way to navigate documents. And you can imagine like the DOM tree, if you just walk from one node to the next, and the screen reader reads out every node that you go to, that's basically what the virtual cursor does. It's not super effective, but it works well to actually read documents. Here's a short example with a custom demo page, just to demonstrate what the screen reader does. And here I use the virtual cursor with voiceover.
HTML content. Heading level 1, earthquake notifier. Heading level 2, we provide email notifications for earthquakes. Entering main landmark. To use our notification service, heading email. Get earthquake. Heading level 3, privacy. We only use your email address to leaving search landmark. Entering complementary landmark. Heading level 3, about us. We provide this service for top-down photo of urban destruction image.
So I'll leave out the rest. But what you just heard was the alt attribute on this image element. So that's basically the reason why you're supposed to put the alt attribute there, so that the screen reader knows what this image represents. Of course, going node by node is not super effective, so there's other ways to navigate when using a screen reader. And instead of just going from one node to the next, or element, screen readers support going directly to certain elements, kind of like go-to. And the elements that you can go to are usually headers, links, forms, and landmarks. The first three should be like pretty common. It's nothing special. Landmarks refers to regions like navigation, content, of search, or footer. So those are special. In this video, I'm showing what it sounds like when trying to navigate this page with the web item rotor, another voiceover feature. To navigate with just the landmarks.
Landmarks, 5 items. Banner, main, complementary, search, content information, headings, 5 items. 1, earth 2.
And then there's headings, and this page doesn't have links, so those don't show up, but it has a form. So if you've never heard of landmarks before, I want to show you a quick example how to use them. It's pretty simple. Basically, all you do is add a role attribute to certain elements. Here are a few examples of the value for the role. So it pretty much depends on the purpose of the element. So it's supposed to have some kind of semantic meaning. So, for example, the sidebar on the demo page to the right gets the role complementary, and the role main is used for the main content. And in this case, it also actually uses the HTML5 main element. For now, it's recommended to use the main element with the role main. Eventually, we can probably drop the role on that main element, since the screen reader will just know the role of that special element. There's some interactivity on this page in this form. Like when you submit it, there's actually some Ajax going on in the background. And I want to show you what currently happens without some special consideration when we submit this form.
Email, required edit text. O-N, ton, Y, ton, at, G-A-L-M, com. You are currently on a heading level 2 inside.
So as you could hear, there was not much to hear after submitting the form. It would actually don't tell us anything about this loading indicator, and there was no confirmation message that the form submit was successful. Instead, VoiceOver actually gets bored and starts reading a now invisible heading instead. This is something called unexpected screen changes. If you look at surveys of problems that screen reader users have, this shows up pretty often, usually somewhere under flash and captures. This is one of the major reasons why we need to do testing, since captures are easy to identify, they always suck, but this type of problem is harder to detect. But it's not that hard to fix either. In this example here, so to make this work on this particular demo page, I use more special attributes. So I use area live with the value of polite. Area live basically tells the screen reader this is something that will change. And polite means let the screen reader finish and then announce the changes. And area atomic, which is used in the second element here, tells the screen reader read all the text of this element and not just the one that changed. The JavaScript for this looks a little like this. This is not an actual form submit, I just use a timeout to simulate the delay that the server request would have. And here, pretty much all I do is make things visible at a certain point in time by removing this hidden class and then actually changing the text content so that the screen reader can notice this change in the live region and then announce that change. And it's important that you actually make the text change. If you just show and hide elements, the live region doesn't actually care about that. So with that in place, the submit sounds quite different.
Email, required edit text. DAVID at GMAIL period COM. Subscribing, David at gmail.com. 2. Thanks for your submission. We will send you one email to david@gmail.com. Confirm your address. We hope.
So that's obviously much better. Now, VoiceOver announces both changes, and this is something that even the screen reader user can deal with and just can use normally, not get these unexpected screen changes. And so what I used here to make this work are attributes from ARIA, aka the Accessible Rich Internet Applications specification. This is a W3C standard, and it has two major aspects. It has roles, like the landmarks roles we've seen, and it also has widgets. I want to show you examples of this in a moment. And there's a bunch of states and properties, like the area live and area atomic that we've used already, and a bunch more that I will also show you soon. Area has its own problems, the implementations aren't perfect, screen readers sometimes behave different. So, as usual on the web, it helps to look for existing solutions. jQuery is providing accessible widgets that are already tested with the screen readers, and they do the necessary workarounds where they are needed. And I want to show you two examples, the menu and the autocomplete widget. Here is a very heavily simplified menu example. There's two menus, one with two items and one with a nested menu under it with another item. And this is mostly so I can actually show you the full markup. This is just slightly simplified. This is most of the markup that the menu widget will use. And pretty much every element except the icons have a role. So there's menu, which is used for the containers. There's two of those. There's menu item for the items itself. And there's presentation, which basically indicated that this particular element doesn't have much semantic meaning. So those can be ignored. And then it uses a few more attributes for some other stuff. If you use that menu with VoiceOver,
open menu item, menu 2 items. Open recent menu item. My first document menu item, menu 1 item, level 2. Open recent menu item, menu 2 items. Open menu item.
So as another example, the autocomplete widget. This is what we're going to look at. This is also using the menu widget for the actual menu, but in order to announce what happens to the screen reader user, since the focus always has to stay in the text input, the autocomplete widget has to do some workarounds. This is not really what the specification for area for autocomplete says you should use, but if you do that, it doesn't actually work anywhere. So what autocomplete does, it uses a live region, it gives this element a role of status, which helps to make announce changes. It hides it from the regular user, so with this class UI hidden, and again it makes this a live region. And then it just updates the text content depending on what's happening. So it either announces their elements, and you can use the cursor keys, or there's no results.
Tags, edit text. J, 3 results are available. Use up and down arrow keys to navigate. J, A, 2 results are available. Use up and down. V, Java. SCRIPT, JavaScript.
So, not in this video, but if I would have typed something that doesn't have a suggestion, it would actually read no results available. That's the examples I have. Obviously, there's more widgets in jQuery, and those use other attributes and roles. As for the future of both Area and jQuery, both of them aren't done yet. Area isn't fully implemented anywhere. There's more widgets that we could implement. Some of the existing widgets aren't as accessible yet as we want them to. But since the jQuery Foundation is a member of the W3C and influences standards, you can actually help in like both these projects. You can support jQuery and the jQuery Foundation and talk plenty about actually supporting the code project. If your company is interested in joining the jQuery Foundation as a member, that will also help. So to recap, we know that there's people with disabilities that benefit from technology. We've gathered arguments for convincing our bosses, clients, or coworkers to actually value web accessibility. We've seen how to test basic keyboard accessibility as well as screen readers. And we've looked at solutions for fixing issues, for fixing the problems we find by hand or using frameworks that are already accessible. And I hope I could convince you that making websites accessible is worth it, and maybe you can help the next Stephen Hawking. So thank you for your attention. I'm not sure we still have time for questions. I guess you'll just have to ask while we wait for Adam to announce the next talk. Yeah? Yeah. So please, questions. Yeah. Okay.
There are some cases where there wasn't any way around making something accessible without having to rewrite a different type of interface entirely.
Okay.
And as far as kind of sniffing that type of reader device, not only designing, of course, in standard ways is best for that, best as it can, but in the time where you don't really have an option and you do want to make it accessible. What kind of experience do you have there with shifting a reader over to reading something completely different than what's on the normal?
So to summarize, I think the question is about when you get in a situation where the interaction that you designed, you have to basically replace it completely to make it at least a tiny bit accessible. What can you do there? So this example that I showed is from Amazon.com, and I guess they, a few years ago, made this separate site and they found a trick to announce this only to screen reader users, and then just abandoned it, apparently, because that obviously is not well designed. In general, as far as I know, there's no way to like, sniff a user agent or sniff a screen reader user. It's just, there's no, like, as far as I can tell, there's no direct way to do that. I mean, they do a trick where they put in hidden element that the screen reader user sees, or hears rather, but I can't recommend to do that at all. As for actually, like, what to actually do when you're in this situation, it's hard to tell. That's probably why it's so important to keep accessibility in mind from the beginning, just like you need to keep like security and user experience in mind, since if you ignore that and then try to make it work later on, it can get really tricky. So I don't really have a good actual good answer for that. Yeah?
What kind of accessibility works do you see coming out for things like web performance and how Angular? When somebody asks about semantic web, this sounds like it would be even more.
So how do you, like Angular, basically how do Angular and accessibility work together? So in general, like if you do a lot of like single page applications where everything happens in the client, if you don't test it with the screen reader, it won't work. Obviously it's possible to get a lot of dynamic stuff working with Area and like live regions, but live regions have a like very specific model, like they only react to text changes, like they either read new text or read everything if content changes. So just hiding and showing elements, that doesn't really work for the screen reader. So, I mean, I don't see any reason why you couldn't make an Angular app accessible, but you really have to test it. And if Angular does anything to actually help you with that, I can't answer it. And I know that, I guess, if you use, for example, if you use jQuery widgets within an Angular app, then at least the widgets that jQuery provides should be accessible. If the user can actually use the stuff that's around that, it's another question. Yeah, follow up? I'm not sure if I understand that question.
So you hit the enter key or you tap down, there's no other information coming.
Okay, so I guess in trying to figure out if the user uses a screen reader, so since pretty much all the screen readers use different key combinations, I think that would be a lot of work to implement. Like, so VoiceOver uses like control command, I think, or something. On like JAWS used mostly the insert key, and then other combinations. There's not much consistency there, so I think like you would still have to test every screen reader to see what combinations the user might use to detect that. I think area is like the specification to build on there. Obviously, it has its problems. It's not fully implemented in all browsers, and especially JAWS used to be behind the implementation for a long time. But I think actually like the area is kind of awkward since all of that should actually be just part of HTML. But since getting stuff into the HTML specification tends to be pretty difficult, became its own standard. It's like all the area attributes are valid HTML, so the validator doesn't yell at you for using these attributes, but it's still separate while it actually should be one thing. And I guess with the main element, we have one example where you can replace row main eventually with the main element. So I think like pushing these standards forward and then actually report, for example, you can actually report bugs for NVDA since that's I think an open source project. So it's not trivial to get all this moving forward since most people still don't much care about it, but at least there's been a lot of progress. Okay, thank you very much.
Thank you.